All right, in this next example, we're going to look at is actually having gates. So we can look at how we use logic gates. So to start setting up these logic gates, I'm going to have that we have two inputs to the gate. So I have two switches, one for input one and one for an input two. And then the output will have this blue LED show the output. So to see your gates, on the search, you're going to type in gate. And then we have a few different gates that pop up. So items that say quad, so like this quad AND gate, there are 4 AND gates on this chip. You see that some of them say 3 inputs, so that would be a 3 input gate. The gates that we have, so it's important to acknowledge this, is that we have ANDs, ORs, XORs, and NANDs, and NORs. You see that we do not have any NOT gates. So to make the NOT gate, you're going to have to use either the NANDs or the NORs. So we have the ones that don't say inputs, those are just 2 inputs. So NAND, NOR, and an OR. These top ones, there's 4 of the gates of 2 inputs. You see we have a 3 input AND, NAND, NOR, and then on some of them we have 4 inputs. All right, in this example, let's just do an AND gate. So let's take this AND gate, and then we're going to have to rotate it. That went too far. Okay, so we'll do this, and then we'll have everything get connected in. Okay, on these AND gates, if you hover over the pins, you would see that it has some labeling that pops up. So this is there's 4 AND gates on here. So this one says it's input 1 for the A gate, input B for input 1B. So these are the first gate. So you have input A, input B, and then you have the output for 1. You have the input for gate number 2, the input for gate number 2, the output for gate number 2. And then this one shows we have a ground. We have to wire up our ground. So we'll connect the ground to the minus sign on here. Let's go to the other side. Here we say we have power. This power needs to connect to power. So let's do it on the right-hand side since we're closest to that. I'm going to bridge over the power on both sides. And then we have gate 4, input gate 4, input gate 4, output gate 4, input to gate 3, input to gate 3, output to gate 3. Okay, we're just going to connect input 1 into gate 1, A. This will be input B to gate 1, B. And then the output, we're going to connect to our LED. So since I'm right here, let me go ahead and connect my output. My output, I'm going to connect it onto row 18. So that's the add node item on the LED. And so we know that's not power, and that's like a logic gate. Let me do that in yellow. So then I need to do input B. So I'll do B. I'll change that to a different color so I know that this is for B. And then I need input A. I'll connect input A. You know, I'll do these in green so I know those are all for gates number 1. Let me go back and I'll put this as green so I know all that belongs to gate number 1. You know, if we're using like a gate 2, maybe I use gate 2 in a different color. Maybe I use yellow for gate 2, orange for gate 3. All right, so now we have input 1, input 2. We have our AND gate, and then we have our output. So let's simulate it. So input A is 0, and we have input B is a 1. 0 and 1 ANDed together is a 0. We see the LED is off. I'll switch the top one to an on. Now it's 1, ended with 1, output of 1. And here you would see, because now we're going through actual circuitry, we don't get the warning about too much current going into the LED. So this is how you would set up the breadboard. Now, in the case that in the assignment I give you, you cannot fit all the components on one breadboard. You can always have 2 breadboards. And the same idea that you need to know, you connect the wire, the positive to the positive, the minus to the minus, so that power moves between the 2. And then you can have the other gates set up. All right, that should be enough. You can get started with the assignments that we're going to be doing.